we'll get started. And this is on page, so we're starting 3.1. This is on page 162. And one of the things I'd encourage you to bring to class, in addition to your pencil, is maybe bring a red pen, a black pen, a blue pen. If you have other fancy colors that you love using, bring those. Highlighters, because sometimes in our notes we'll color code things. Sometimes in our notes we'll highlight things. So if you have that, it can be really helpful. I'll show you what I mean with some color coding here. So they gave us a parabola that we already know, y equals x squared. And this idea of inside and outside also works for parabolas. So on your regular parabola graph, you know that you have a vertex at 0, 0, 1, 1, 2, 4, and by symmetry you have those points. So from grade 11, you probably would have been able to find those 5 points really quickly. And some strategies you might have remembered is like it goes over 1, up 1, over 1, up 3, over 1, up 5. And now in blue, we're going to look at what happens when we add something after. So right beside this 3, I'm just going to rewrite x squared plus 3 in blue. And besides the minus 3 in green, I'm going to write x squared minus 3. And we're going to look at what happens to the graph when there's a number outside. And so we did that activity already. We might have seen that all numbers outside affect things vertically. So the y equals x squared plus 3 is going to move this graph up 3 units. So we can take those 5 points and draw it up 3. And by color coding it, what's helpful about color coding it in your notes is that like when I'm done all 4 of these, this thing is going to be full of graphs. If you did it all in pencil, which is fine, it's going to be very busy. But by color coding it, I can immediately make the connection of, oh, the blue graph went with the blue equation. And x squared minus 3, shifting it down 3, and doing those 5 points. Now I can make the connection with the blue graph, the green graph going with the green equation. At the bottom, we've got h equals negative 3. So that would show up as negative 3. This would be x plus 3 squared. And in purple, x minus 4 squared. So what we see here is now the numbers are inside the function. They're going to get squared. Whereas the blue and the green, that 3, the squared, doesn't affect it. When things are inside, we talked about our x's being liars. Your gut would probably see a plus 3 and want to go 3 to the right, but it actually goes 3 to the left. And you saw this when you did vertex form of a parabola last year in grade 11, that the vertex was the opposite of that number. And so moving 3 to the left, that would take those 5 points and move them 3 to the left. And finally, the purple one would move everything 4 to the right. So if I just used one color, things at the end would look very busy and very much the same. But now my brain can quickly correlate which graph goes with which equation, and that can help you studying later, help you see things quicker. So sometimes we'll use color coding. Now, the textbook nicely color coded the next example for me, but it's like, even with colors, it's way too busy, and then they have it for you not in colors, so we're going to skip this, because it's helpful, but it's just too busy. But we're going to turn through page 164 and just talk about some of the things we've seen already. Okay? So what they have here is they got our square root graph, and if you had a plus 2 outside the function, that would move it up 2 units. If you had a minus 1 after outside the function, it would move it down 1. Now I'm going to color code something here as well. I'm going to put this in a green box and this in a blue box. Can you see that what's in the green box is exactly the same as this equation in green? What did they do? How are they the same? Why are they the same? Same thing with the blue one. I'm going to say that this equation in the blue box is the same as this equation, but they did something simple. Do you see what they did? You see that they moved the one over to the other side? So, preference. There are some people that really like having the numbers on the side with the y, if it's outside. Me personally, I like to have it as it is beside the equation after, because then it's exactly what you see. If I move it with the y, you see that it's opposites again? So, something to be aware of. That number could be on either side. It's simple arithmetic to move a number from one side to another. I'm going to mainly deal with all the numbers on the side and y by itself. So then when I see the plus 2, it goes up 2. Here, it's y minus 2. So personally, if I had this, I would probably go, oh, I'll just switch this to look like this. Then my brain says it's outside the function. I see the plus 2. It's going to move it up 2 units. But the questions could appear rearranged, so you just have to be prepared for that. And same thing here, we have the x cubed graph, so this plus 2 would move it 2 to the left. This minus 3 would move it 3 to the right. And that's that basic idea that we've done. Sometimes in your textbook, they highlight everything in a general form in these shaded boxes. Okay? So the general form says if there's any number h in there, that's either going to move it left or right. If there's any number k by itself, either on this side or moved over, that's going to move your graph up or down. And it doesn't matter what your graph was originally. So like, both of these are not parent graphs that we did. They're just like, look like random graphs. This one looks like 2 straight lines glued together. You can still take that graph and move it up and move it down. So not only will we get examples where we have an explicit equation where it gives you the equation and some sort of function with x, we are also going to get some questions in function notation. And they're going to say, this is some random function f of x. If I gave you x minus 2, you would take it and move it 2 to the right. Even though you don't know what the equation of the original function is, you can work with it in function notation as well. And that'll be one of the things that we do a fair bit in this first examples. Now when we get to example 1, in example 1, yeah, here we go. On page 165, they give us the graph of g of x. And again, it's a graph you do not know the equation of. It looks like actually 3 lines glued together. It says, sketch the image graph after each translation, write the equation of the image graph in terms of the function g, and state the domain and range of each function. So I'm going to do A in blue. A translation of 4 units to the left. Well, actually graphing it, 1, 2, 3, 4, and taking all the points and moving them 4 to the left is not very hard at all. And then you get to play a little bit of connect the dot. Oh, so much fun. There is our new graph. Moved 4 to the left. Now I'm going to tell you, you will be very tempted to do this in math. You're like, woohoo, I graphed it 4 to the left, and you see B1 up. I can do that too. You'll probably graph it 1 up and then turn to go to your next question. Now on a quiz or a test, that can be catastrophic. Because this question actually asked us to do a whole bunch of things. And one thing that's different in math than any other subject is you have to read and then reread and then reread a question. And when you're finished, I tell you to read the question again, because it's often that you're going to miss something. So we actually did the first thing. We did the first sentence, sketch the image graph after the translation. That's done. But the second part says, write the equation of the image graph. Now I'm going to take out my highlighter, because this language is sometimes confusing. In terms of. The in terms of part is telling you what you need on the right side of your equation. In this one, it says in terms of the function g. So I'm going to write an equation. On the left side, I'm going to have y equals, because that's a graph equation that often has y equals. And on the right side, I need the equation g. Well, in function notation, I've moved things left and right. We've talked about left and right is inside the function. And x is lie, so it's going to be the opposite of what I see. 4 to the left will actually be a plus 4. And that plus 4, x plus 4, happens inside the function. What's the function? The function is g. So this is writing this in function notation. Sometimes we have actual equations like the square root, the x cubed. We can write the actual equation. This is the equation in function notation. So write the equation of the image in terms of the function g. On the right-hand side, I need the function g. And here, I needed to show that the function g was moved 4 to the left. So that's what this language is telling us right here. This g of x plus 4 says the original function g, which is the red one, you took it and moved it 4 to the left. Is that what my graph shows? Exactly. So one of the things that we learn in math is like learning a new language. How do we say things in mathematical language to describe this? Now for the blue graph, it also says state the domain and range. So for my blue graph, the domain, my x values, well, they start at -5. I'm going to do interval notation for this one, and they go to +2. So what I'm going to do in these first ones is I'm going to switch between interval and set, so you get used to both of them, but I won't do both of them all the time. You get to choose on a quiz or a test or on the exam. If they say write the domain, you get to choose. Which one do you feel more comfortable with? Sort of rule of thumb is if you're doing a question that has a whole bunch of interval notation already, and they ask for the domain, sort of like you should answer in that same one. You would still get it right if you decided to switch it, but it's sort of like etiquette-wise, if a question is in set notation, you answer in set notation. It's probably like if you spoke different languages and you met someone and they started speaking to you in another language that you knew. Let's say you know French. They start speaking to you in French. And you just decide to respond to them in, I don't know, Chinese? That would be your response probably is not wrong, but it would be a little weird, wouldn't it? So, there's my domain, my range are my y values. So in interval notation, I always think about what's my smallest y value, it's a 2, and that's included. What's my biggest y value, it's a 5. So there's my domain and range for my blue one. Then part B, I'm going to do in green. Translation of 1 unit up. So that, take all of my points, shift it 1 unit up, connect the dot. No problem. My equation now in terms of g. Well, moving things up and down happens outside of the function, so I can just write the function like normal, g of x, nothing happened inside, and then write a +1 afterwards to show that my g of x original graph was moved up 1. And this equation is in terms of g because I have g of x on the right side, and I'm showing that the transformation that happened was a translation of 1 unit up. And finally, domain and range. My smallest x value now is -1. My biggest x value is 6. My smallest y value is 3. And my biggest y value is 6. And now that I'm done the equation, I read it again. Here's the graph of g of x. Sketch the image of each graph. I did that. Write the equation in terms of the function g. I did that for both of them. State the domain and range of each function. I did that as well. Now, once we are done a question, what I'm going to get you to do is turn to, and for this lesson, it is on page, starts on page 169. So turn to page 169, and then I'm going to write down 4, 5, 6, and 7. So I'd like you to go to page 169, circle question 4, circle question 5, circle question 6, circle question 7. Those ones would be good to do for practice. I'm not going to assign all of the ones in the homework thing for practice, because some of them aren't as helpful as others, and some of them are like busy work that you don't need to do. But these would be good questions to practice. And then when you go home later, if you turn to your homework section, you see which ones you can do. I also sometimes recommend is if you go back to page 165 at question number 1, write down 4, 5, 6, and 7. Because that's sort of telling you that the stuff you learned here may be helpful in those questions. Sometimes there'll be little new things that they add. Sometimes you'll have to ask some questions. But after what we did in question 1, you should be able to figure out how to do questions 4, 5, 6, and 7.